Okay, so chapter 5, day 1. What we're going to look at is what are normal curves. So this is new. This is stuff that's used a lot around society. But what are normal curves and how do we use them in calculations? So we're going to start out today with normal curves. So a normal curve is a curve with an area of 1 under it. So you're going to draw a normal curve and it always adds up to 1 under that normal curve. In general, it follows what we call the 68, 95, 99.7 rule. What does that mean? Okay, so I have a normal curve that's drawn and I lay out 0 as my center for standard deviations. Then I lay out 1, 2, 3 standard deviations to the right, and those are positive. 1, 2, 3 standard deviations to the left, those are negative. The 68, 95, 99.7 rule says approximately 68% of all observations will fall from -1 to +1 standard deviations. 95% of all of our observations will fall between -2 and +2, and 99% of all of our observations fall between -3 and +3. So if this was height, for example, here's our average height. 68% of the people lie within 1 standard deviation of the height for what's average. 95% of the people are within 2 standard deviations, 99.7, or almost everybody is within 3 standard deviations for height. So here's some questions that we can ask. All right, so definition, first of all, percentile. Percentile is a word that we're going to hear, or it's a word that you're going to hear as you go through your life. It is the percent of data that is below or on the graph to the left of a given value. So, for example, this is the location right here, this line right here is the location of the 90th percentile, because 90% of the data is to the left of this, or below if this was a number line right here. So percentile by definition is the amount of data to the left of any given value. So for example, here's the location of the 90th percentile. So let's look at some questions. If height is normally distributed with a mean of 65 inches and a standard deviation of 2 inches, find what percent of people would be less than 63 inches. So a mean is 65, standard deviation of 2. If they tell me it's normally distributed, then the first thing I have to do is I have to draw a normal curve. Mean is, I believe they said 65 inches, and a standard deviation of 2. So I mark the 65. I drew that. Draw it again. So 65 is in the center. Standard deviation of 2. So 65 plus 2 would be 67. Plus 2 more, 69. Plus 2 more, 71. And this is 0, 1, 2, and 3 standard deviations away from the mean. Backing up 2 at a time. This is 63, 61, 59. I have to draw this curve. This is -1, -2, -3. I have to draw this every time for every new problem. So what percent are less than 63? So I need to look at where I am. So 63 is at -1. And I'm going to shade the area I want because it's less than. And I'm at -1 heading this way. Well, let me go back to my chart. So that's -1 heading this way. I need to get these percentages in here. So let's take a second and figure out what all these percentages are. If this is 68, then half because it's symmetrical, would be 34 and 34. If this is 95, take away 68 and take half of that. This is 13.5, 13.5. So 99.7 minus 95, take half. This is 2.35, and this is 2.35. By the way, you will get this chart if you have any test or quiz. You'll get that chart. And what's out here on the tails is 0.15 and 0.15. So given this information, I'm less than 63, which is less than a -1 standard deviation. So from -1 over, that's what I have to add up. So I just add these up, 13.5 plus 2.35 plus 0.15. So I'm going to take 13.5, 2.35, and 0.15. That's what all of these regions are. This one is 13.5, this is 2.35, and this one here is 0.15. All three of these added up comes up to be 16. So 16% are less than 63 inches. So it's a matter of drawing the curve, laying out your deviations, and then adding up the percentages depending on where they tell you to go. Let's take a look at a couple more. Taller than 69 inches. Well, I have to draw a new curve. I can't just use the same curve every time. So again, my mean was 65, same mean. So here's 65, and then I go 1, 2, 3. 67, 69, 71. 0, 1, 2, 3. You have to have that every time. So taller than 69. So that's over here. So 2 and higher. I go back to my picture. 2 and higher is the sum of 2.35 and 0.15. So 2 and higher, I've got 2.35 and I have 0.15. So 2.35 plus 0.15 is 2.5. So 2.5% are taller than 69 inches. Rough estimate, on average, using the 68, 95, 99.7 rule. What percent are between? So here's the graph, the same one drawn again. Again, I lay out the mean, 2, 3, -1, -2, -3. So I'm from -1 to +2. So I go back to my chart. I start at -1. And I go up to +2. So that's 34, 34, and 13.5. So I go to my problem, and I have 34, 34, 13.5. So 34, 34, 13.5. So add these up, I get 81.5%, right? 68, 78, 81.5% are between those two. Last one, what percentile is someone in if they are 61 inches tall? So again, percentile is at and below. So I lay out my 65, 63, 61, 59, 0, -1, -2, -3. I'm at -2 and below. Well, from my chart, this is 2.35 and this is 0.15. So again, if I add up 2.35 and 0.15, I get 2.50. So what percentile? 2.5 fifth percentile. I don't know how to say that. The 2.5 percentile. But so this lesson is all about just using this chart. Okay?